In November 2019, a normal dinner service at a commercial restaurant in Burlington, Massachusetts was underway. A worker spilled an acid-based floor cleaner on the tile. To clean it up, a second worker grabbed a chlorine-based cleaner and poured it directly over the exact same spot. Within moments, the mixture on the floor began to bubble. The liquid turned a vibrant green and started rapidly foaming across the tiles. The manager did what any hands-on leader would do. He grabbed a squeegee and leaned in, trying to push the liquid toward a floor drain. That proximity put him directly over the vapor. He collapsed and did not survive, and 13 other people in the building were taken to the hospital. Both chemicals were ordinary commercial products, doing exactly what they were designed to do. No one acted maliciously. This was a routine cleanup that exposed a massive vulnerability in how kitchens handle their supplies. When sodium hypochlorite, the active ingredient in bleach, meets an acid, the molecules violently break apart, releasing chlorine gas. There's no slow buildup. It reaches lethal volume in seconds, creating a rapidly expanding cloud. If mixed with ammonia, it generates chloramine gas, another highly toxic vapor. These vapors naturally hug the ground as they expand. When a person leans over with a mop or a squeegee, they place their respiratory system directly into the most concentrated zone of the gas. Because the vapor expansion is immediate and targets the lungs, trying to physically clean up a mixed spill guarantees exposure. Commercial chemicals are heavily regulated. When they arrive from a supplier in bulk drums, they carry intact, highly visible safety labels. The risk appears the moment a worker pours that bulk liquid into a smaller secondary container to carry through their shift. Under workplace safety rules in Canada, if you fill a spray bottle and don't use it up immediately yourself, that bottle requires a detailed workplace label carrying the exact safety information as the original drum. Yet, walk into almost any commercial kitchen, and you will find shelves lined with identical, completely unmarked white spray bottles. Without a label, a regulated acid and a regulated bleach look exactly the same. The safety chain breaks, leaving an invisible hazard sitting on a shelf, waiting for the next shift to guess what's inside. The manager in Burlington died because of a deeply ingrained human instinct. He saw a spill on his floor and tried to contain it. If two incompatible chemicals meet, you cannot mop it up, you cannot squeegee it, and you cannot try to dilute the bubbling liquid with water. The only correct response is to evacuate the area instantly, take everyone with you, ventilate the space from the outside, and wait for emergency services to clear the room. But teaching employees how to run away from a toxic gas cloud is a fragile defense. True safety means ensuring the reaction never has the chance to happen in the first place. Safety posters and training binders are easily forgotten on a chaotic Friday night. You cannot rely on human memory to prevent errors under pressure. The most effective control is elimination. Swapping chlorine bleach for a registered hydrogen peroxide disinfectant cleans surfaces just as well, but entirely removes the risk of a chlorine gas reaction. Next are physical controls. Wall-mounted dilution dispensers automatically mix the correct ratio of chemical to water and fill the bottle directly, removing the need for employees to manually pour from a bulk jug. Finally, visual systems remove the guesswork. By assigning strict color codes, a red bottle for sanitizer, a blue one for glass cleaner, the tools match their specific wall dispensers and cloths. In a properly engineered kitchen, a worker doesn't have to guess between two white bottles. To make a fatal mistake, they would have to actively ignore the color of the bottle, the shape of the cap, and the specific dispenser it came from. Even with physical systems in place, workers need personal protective equipment. Chemical-resistant nitrile gloves act as the final physical barrier between the staff and the formulas they handle. A safe workplace isn't measured by how well a tired crew can read a label. It is measured by how intelligently the environment is engineered to keep incompatible elements from ever crossing paths.